Alright, hello again everyone. So all we're working on today is our 5.5 notes. We're going to take notes on pages 23 through 25. Upload those when you're done. So you see page 23 starts with a review of inequalities. You might remember working on these earlier in the year. To start with, if x is less than 2, we identify 2 as the critical number. That's the number that goes in the middle of my number line. If you remember, I always asked that we had something bigger to the right and smaller to the left. Now you could fill out the other numbers if you want, but once you have the critical number in the middle and something bigger to the right, smaller left, it gives context to know how the rest of the number line would work. So now it's all about shading in or coloring all of the numbers less than 2. Notice that does not include the number 2, so we use an open circle for that to show 2 is the critical number, but it's not part of our answer. And then everything less than is on the left side, so we shade to the left. And that effectively colors in all of the numbers that are less than 2. So quick review through the other 3 examples here. Again, critical number 2, fill out your other numbers. Again, not equal to 2, so 2 is not part of our answer, but this time we want everything greater than 2. And that goes to the right, like 3, 4, 5, etc. In the next 2 examples, you'll notice the difference is now there is a line underneath the inequality. That's that or equal to line. So now that tells us that we want everything less than or equal to 2. So now equal to 2 is part of our answer. And still so is everything less than to the left. And one last time, the equal to tells us that 2 is part of the answer. And the greater than tells us it's everything bigger than 2, like 3, 4, and that goes to the right. So in short right here, we can summarize by saying we use an open circle whenever it's not equal to. So that's the less than symbol and the greater than symbol, because they are not equal to. We use the closed circle right here and right here for the less than or equal to symbol and the greater than or equal to symbol. And that's because they are equal to. We shaded to the left in each of these examples whenever we used a less than symbol, whether it was equal to or not. Less than or equal to is when we go to the left. And finally, we shaded to the right here and right here whenever we used a greater than symbol, whether it was equal to or not. So that's a review of inequalities from earlier this year. And right down here, it tells us that the next thing we're going to do is start graphing inequalities that now have 2 variables. So instead of just one variable, like just the letter x, now we're going to work on problems that have 2 variables, like x and y. This means we're combining what we know about lines, linear equations, slope, intercept, all that good stuff, with what we just reviewed about inequalities, like how to shade and show all the different answers. So turn over to page 24. And right up here, we're going to fill out some step-by-step directions for how to graph a linear inequality. Linear inequality now that there's x and y. We're going to fill these steps out as we do this example together, so kind of bouncing back and forth. So let's start with, right here, the first step we're going to do for a linear inequality is solve for y. And right away, this is a little different than if it was a linear equation, because you might notice this is written in standard form, ax plus by equals c. And if it was an equation, if that was an equal sign, we could do y equals 0, find the x-intercept. We could do x equals 0, find the y-intercept. And using our intercepts, we'd be able to graph the line. The problem is when it's written this way, it doesn't help us know which direction to shade. What side of the line are we going to color in? So for inequalities, it's real important that we always start by solving for y. And by the time we get to the end here and actually do our shading, you'll see why it's so helpful. So bringing it back to this example, I'm going to put my line down the middle and start to take some steps to solve for y. For instance, moving 3x to the other side with a minus 3x. Bring down negative 2y, bring down the inequality symbol. For 8 minus 3x, I'm actually going to flip that order. I do negative 3x plus 8. And that's just the negative 3 up front, the positive 8 in the back. Continue to solve for y by dividing everywhere by negative 2. And right on this side, when y is all by itself, well, this is a good time to pause and remind ourselves of another thing we did with inequalities earlier this year. And that's whenever you divide by a negative on both sides. And here we are dividing by -2 on both sides. Remember, that means you need to flip the inequality. So if we could actually go back up to step 1 here and make a special note to remind ourselves that while step 1 is solve for y, it's important to remember to flip the inequality if you multiply or divide by a negative. Okay, so that's, remember to flip the inequality if you multiply or divide by a negative, just like we just did. So continuing to simplify the right side, negative over negative cancels. This becomes positive. That looks like a fraction, so I'm going to leave it like a fraction. While positive 8 divided by -2, positive by negative is negative, and 8 divided by 2 is 4. So I get y greater than or equal to 3/2 x minus 4, which brings us up to step 2. We're now going to use a point and slope to plot more points. So, for instance, and sorry, leave that for 1 second, let's use a point and slope to plot more points. So we need a starting point. In this problem, we have a y-intercept of -4. So I'm going to start on the y-axis at -4. We also have a slope of positive 3/2. And so that's up 3, right 2. I'm going to go up 1, 2, 3, right 1, 2. Can do that a couple of times. Up 1, 2, 3, right 2. Okay, so now this brings us to steps 3 and 4, which is really where inequalities are different from equations, because so far this is all something we could have done for an equation. And if it was an equation, we would draw our line and we'd be done. So what that tells us is that when there's an equal sign here, the equal sign is represented by a line. The line is all of the points where y equals this stuff. And so in this case, y does equal this stuff. It's also greater than, but this is an or equal to. So in step 3, we have to decide to use a solid line, and that's just like we did with equations. We always used a solid line. So that's anytime it is equal to, like greater than or equal to, or less than or equal to. But for those examples where it's not, then we can choose or a dotted line. And this is kind of like our closed point. Solid line is like a closed point when it's equal to. Dotted line is like the open point when it's not equal to. So in this case, it is equal to, just like a regular equation, so we draw a solid line, just like a regular equation. Then the last thing that remains in step 4 is, of course, this wasn't just an equal sign, there's also that greater than symbol. So we want not just all the points that are equal to, that are on the line, we want all the points that are greater than this as well. And that means the last thing we do is decide to shade above or below the line. And we're going to shade above, think going up, getting bigger whenever it's greater than or equal to. We're going to shade below, think going down, getting smaller whenever it's less than or equal to. So this problem, greater than, is going to shade above. And what that literally means is you put your pen, pencil, finger on the line and move up. Think of how this line is kind of cutting the graph into 2 pieces. There's the big piece up here. There's the smaller triangular piece down here, right? This line is kind of cutting this graph into 2 pieces. We're going to pick which side do we color in by going either above or below the line. So when I put my pen on this point, and I think greater than goes above the line, I move straight up, I see which side of the graph I'm on, that's the side that I shade in. And what this means is that any point on this line, you could put X here, Y here, and it would make this true. Any point over here on this shaded side, you could put the coordinates, pick a point, any one you want, like 1, 5. You put a 1 right there, you put a 5 right there, you'll find that 5 is greater than or equal to whatever you get over there. Now anything down here that we didn't color in, these would be the points that don't work. So quick review over here, we used a solid line whenever it was equal to. We will use, in a next example, a dotted line whenever it's not equal to. We shaded above in this problem because it was greater than, or in this case, greater than or equal to, and we're going to shade below in a future problem whenever it is less than or equal to. My pen's dying there, let me switch. So less than or equal to for shade below. So let's do another example or two and we'll finish this up. Starting with number 1. So if step 1 is solve for y, this one's nice because it is already solved for y. We're in good shape. So now I'm going to use a point and a slope to plot more points. I'm looking for a point, maybe the y-intercept, -3, and a slope, looks like 4. That's 4 over 1. That's up 4, right 1. So I'm going to go up 1, 2, 3, 4, right 1. And let's do that one more time. Up 1, 2, 3, 4, right 1. So now just like I would have done a line, except at this point now I have to decide what kind of line to use. If this was an equal sign, I'd draw a solid line, but you'll notice there is not an equal line this time. So this is a good time for us to choose that dotted line. And you see how I do that? Just basically dash, dash, dash where the line would be. It creates the same border. It still separates the graph into 2 pieces, but now that dotted line shows everyone, but the line itself is not part of our answers. Our answers are only going to be above the line. So now I'm looking at the greater than, and I want to go above the line. So pen or pencil on a point, move up so you're above that point. Look at which side of the graph you're on, and we ended up over here again. So all the points over here would make this true. All the points down here would not. And in fact, this time, if you picked a point on the line, like right here, 2, 5, that would not make the equation true, because that point would make it equal, and this one is not equal. So these don't work, and anything down here doesn't work, but all your points up here do. We're going to do one last example together. We'll do number 3 down here. So I'm going to go a little quicker this time. Solve for y. I get 2y less than -2x plus 10. Then divide everywhere by 2. I don't need to flip the inequality this time, so it's still a less than symbol. And I get -1x plus 5. So now I'm going to plot some points using a y-intercept of 5 and a slope of -1. That's like -1 over 1. I'm going to go down and to the right. Down 1, right 1, down 1, right 1. Now don't draw your line out of habit right away. You have to pause and ask, what type of line should we use? So I see right here there is not an equal. That means I'm again going to choose this dashed line. Dashed or dotted. And then I'm looking, since the line is not part of my answer, I want to see, well, where are my answers? Are they the points that are up here or the points that are down here? And this time it's a less than symbol. So I put my pen, pencil anywhere on the line, anywhere you want, and for less than, then I'm going to go below the line, which means move down. And again, if the line is cutting the graph into 2 pieces, there's this piece up here and this bigger piece down here. When I go on the line and go down, I end up in this big piece down here. So I'm going to shade that in. And again, it means all the points down here are solutions to this problem. If you picked any x, y point right here and put it in the problem, it would work. If you pick any point up here, it would not. And this time the line does not work. So the line only works in an example where there's an equal sign, then the solid line is part of their answer. But when there's not an equal sign, then the dotted line is not part of the answer. We're going to leave problems 2 and 4 blank for right now. That's totally okay. At this point, if you could take pictures of pages 23, 24, and 25. Upload them to show me that you finished the notes. That's all for today. Thank you very much.